Hey guys, welcome to another video of Exploit Pack. On this one, I'm gonna show you how to unpack a UPX manually and quite simple. Also, I'm gonna walk you through P3 tools from BlackBerry, and also I'm gonna show you an script that I just made to detect anti-debugging techniques directly on IDA. It's an IDC script. Um, all right. Well, for that, let's begin. So let's do it quickly. So I'm gonna use this crack me, and as you can see, uh, it is not packed. So let's quickly open it on IDA and choose views, opens view strings, and then you will see that yeah, you can dump the string, so you can basically see all the sections. And if you do open views and then show the segments, you will see that it has the regular segments on it. So let's close it. All right, so what we're gonna do now is we're gonna choose open a shell here, and we're gonna call UPX. I just got UPX from their website, so it's a UPX, the open source project. So UPX download, and you can get it from this site. Um, this one, yeah, download release, and then you can select the one for your operating system. All right, so we close that, and then once you get it, I'm running it on a Windows machine on a VM, so that's where I got the PA files. All right then, so we need to do UPX like that, and then we're gonna give us an input, the crackme itself, that is was inside here, and then we select this one, and then we're gonna say output, please give me the same one but compressed. So we're gonna do like that, and that's gonna be the output. Enter, and you will see that now the new size has changed, that the compression ratio is 84%. So if we go back to this folder, we will see now that we have the original binary and then the compressed binary here. So yes, let's check that this is again in IDA, choose do it like that, and then we check the sections and the strings again, open views strings, and then open views segments, and then we will see that we have two different segments, UPX1 and UPX0, and the strings cannot longer be seen. So let's unpack it. So now it is packed by ourselves, and we want to go back to the original script. So to the original binary, as you can see, both at running. So let's remove the original, and we are left only with the one that is packed with UPX. So we need to open it in IDA like that. But on this case, now what we're gonna do on this show screen, we're gonna select manual load, so we can select which segments do we want to load into IDA. So we say okay, and now it's gonna give us the image base. We will select the pre-calculated one, and now it's asking us, do you want to load the section that is on this offset based on the image base? Yes, yes. So UPX0, UPX1, those we already got them before, but now is asking us if we want to load a resource and load the header. We say yes to everything. Okay, and now if we look at the segments by doing views, open views, and then segments, we will notice that we have some different segments that are all part of the loader. Yeah. Okay, so now what we have to do in order to export this to get to be able to dump this. So basically, what we need to do, we need to go into the UPX section, and then from here uh, we can directly see. Well, let's first dig into the UPX one, and then I can show you exactly the virtual size. That is this. Then if I go here, I can see that the virtual size is 6,000 hexadecimal. Yeah, so 6,000. Um, that's the virtual size of what is gonna be contained into UPX0. So if we go back into UPX and then so basically the zero, sorry. So go back there, then go into the D word that is pointing into it with the reference. We can get into that jump, set a breakpoint there. Basically, so you can understand why I'm setting this breakpoint here is because basically we have two sections, right? One section contains our compressed binary, and the other section, basically the crack me, and the other section will contain a stub, so basically some code that will decompress during runtime and it's gonna dump our code and then it's gonna jump to it after the compression. So once all this code is run, then it will jump into our new decompressed code on the section that will be whole. On that case, gonna jump into UPX 0. All right. So then we're gonna run it. It's going what's happening is gonna stop into this breakpoint. Now we are on that breakpoint. And now if we press F8, so basically I press F8, that basically is continue the execution. It means that I want to continue execution. And then it's not F9, it's not continue all the way, but it's stepping over. And then what's going to happen is that IDA is telling me, hey, the EIP, the instruction pointer, is pointing to an address that is not defined as code. So basically, it's not in that segment. There shouldn't be code, but now it is. So, but I say I don't recognize this, but I'm still would like to jump. Do you want to jump? Yes or no? If you jump into it, what happens, as I mentioned before, is that you are jumping directly into the UPX0 segment. If we look at the segments now, we will see that, well, of course, we have more segments because it's showing us all the segments, including the stacks and the debug and whatever was loaded into it and the segments for those as well. Um, so, but the interesting ones for us for this binary, because we want to unpack this binary, not what is loaded there, is just these sections, the ones that are on the loader. All right. So we are here now. So we basically from here we are running. So right now on the UPX0, we are executing the code on the binary itself. So that's enough for us. What we could do, we could take a memory snapshot if you wanted. Sorry, yeah, memory snapshot. I said it correct that we can take a memory snapshot so you can debug it back when we stop the execution. But we don't want to do that. We want directly to dump those sections. So we're gonna uh, do it again. So run it, and then we say step over, and then from here is already decompressed. The UPX0 section is already decompressed. So what we can do here is to dump these sections. There are two different these sections. So there are different ways of for doing this. One way is to, well, press Shift F2, or you can say File, a script command, and then you can use the script that I'm gonna give you. that is this one, is dump section, and then you can paste it there, go into the sections, and then you know that it's gonna start here. So these sections, the certain sections are marked with an L, so you need to dump from the beginning till the end. So starting here, that's correct. Yeah, and we need to change this address, the last one. So it's 48, 3 and 3 zeros, like that. What's going to happen is it is going to be the start address to dump from, and then it's going to dump until reach this address. It's going to create a new file, and it's going to write into that file the content of those sections. And the file is going to be called dumpmem.bin, and you can find the file next to your IDA files. So click run, and then it says saves as dumpmem.bin, and then we have it. We have it here. All right. Um, Once we have that, what we have here is we already we cannot run it, but we have it unpacked. So basically, it is already unpacked. So if we close, we can close IDA. Uh, Now we have it here. So IDA created a database from the files that we were running, and then we have the dumpmem.bin. That's our unpacked UPX file, but it's only a dump. So basically, if we want to make it a proper executable, what we need to do is to fix the dump segments. So for that, we can use ptools, sections, right click on these sections, and let's say dump fixer. And now, as I move this window, you will notice that the dump.bin, it is now well, now it has the icon of the program itself. So the segments, they are the offset of the segments, they are now correct. Now what we need to do is to fix the, well, because now if we want to run it, what happens is that almost everything is correct on this binary. Oh, but first, before moving into the IAT, let me show you where you can get the ptools. So from GitHub, and then you can get it from here. You need to go to releases, so releases there. Oops, no, not there. Somewhere here, guys. Yeah. So from here, you go there, and then you can download this one, in this case, because at the moment I am recording this video, this is the latest version, but maybe you are watching it later, so maybe get a new version. All right, so you have it here, and then when we try to run it, still doesn't do anything, so still doesn't work. But if you put it in IDA, you will see that it's not packed. Let's say continue, yes. You see now we have all the functions there, and if we go to see the strings, they are correct, but we cannot run it. It doesn't run because the DLLs that are trying to be used for this binary, they are all screw up. So the import address table is it is not workable. It's not properly set. So for that, we can use this Scylla program, or we can do it manually, but this is way faster, and I want to show you a different or some other ways also to do it. So so first what we need to do is to run a Scylla, then you select the original process. That's what I did. So basically I run the UPX one. That's the original process that has the IAT on it, of course. and the import address table is found now, and we can get the import. So it's using these three DLL, so user 32, kernel 32, and comctl 32.dll. So these ones have a different offset and a different address, and if we what we can do, we can copy this IAT, so this table, and then fix the dump of the one that we unpacked. So you follow, right? Okay, so open, and then now what happens is that we have a new file, a new binary. So we copy the IAT from this guy into this guy, into this dump mem.exe. And what happens is that we got a tier binary with the IAT fixed. And now we can run the binary, and it's oh sorry, I minimize it, and it's uncompressed. As you can see, that the size had changed. Sorry guys, had changed, right? So first it was on UPX it was 8 KB, and now because we have some extra segments there, now it's 30 and uncompressed. So if we drop it into IDA, we will see like that. We will see that it's uncompressed completely, and that we can actually run it. Let's put a breakpoint there, and then say local Windows debugger, and then the application should run and stop into our breakpoint, as you can see here. Yep. Still the the segment where we are running it from is called UPX, because we can change the name for it, so it will so it's called text section, but still it is working. We can still tweak it a little bit more to make it look even better, but still we can. So the important thing is that we can access all the functions that we wanted from the binary, and it's completely uncompressed, right? Let me show you a different way of doing this. So even faster without using, so let's remove it. Let's remove that. Um, okay, let's open the IDA, and on the last run, so now if we run it, we will see that, well, this is still the compressed one, but what we could use here, so now it's gonna jump, and now we are again into our code that is uncompressed. How can we check that? Because if we analyze it, yeah, see, now we land into the UPX0, and this is the actual code of our binary, you see. Well, here what you can do is there are two alternatives. If you want to debug it offline, you can take a memory snapshot of the loader segments, or all if you want, but I will say the loader segments are enough, so those are the one for your binary. And then you can stop the execution and share the database of your IDA with someone else, and the other person will also have the binary uncompressed, but only on the database. Another thing you can do is to use P3. P3 is a tool made by the guys from BlackBerry. And using this tool, what you can do as well is you can also dump from this tool, and you can also rebuild the IDT and the IAT table. So let's go ahead and dump it from here. So we're gonna dump it. So what we are doing now, save. So what happened now is that we made a new dump, but instead of using the this script, the script that we used before, we directly use P3. And of course, P3 has a lot of different functions that we can use, and some other cool features. But this is what I wanted to show you today, so you can also again dump it and even fix the IAT from it. But I'm not gonna fix it yet using it. What I'm gonna do, I'm gonna call it p3 dump, and right now, well, it doesn't work, of course. But what we need to do, oops, we can run this again. This one doesn't run. So what I did, I'm choose run it outside IDA, this UPX one. Then I'm gonna do the same. Select from here, from the process running list, the active process, like that. Get imports, fix dump, and there you go. And now we have it uncompressed, but we dump it using P tools. Okay, so using P3 tools, we're gonna grab that one, and to show you the difference, let's do that. Then let's add a breakpoint there and run it, and you can see it's also running perfectly. All right, so now you know how to unpack manually a binary that is using UPX, and you know two ways. So you can do it directly with a script from IDA. You can choose directly dump the segment, so you can use P3 tools. There are also several other ways of doing it. Yeah, I think you can even use P tools, or you can there are a lot of different ways of doing this. But this I think this is quite useful. So but now I'm gonna show you how to solve this crack me. No, not gonna solve it by itself because that will take some time on the video. I'm gonna keep it short. But what I'm gonna show you is this anti-reversing script that I made. So basically, this crack me, if we try to run it into IDA, you will notice that this crack me will close by itself. So when you run it in outside IDA, it just runs perfectly. But when you run it inside IDA, because or any other debugger, what you will notice is that the crack me, this program, will automatically close. This is because this particular program is using anti-debugging technique. The anti-debugging technique that is using is not being listed here under the imports, but because it's being called directly from as an API. So a trick that you can do is to set out a breakpoint, and then on the export on the first start, and then on this case I already know, because I already solved this crack me that is on kernel 32, is just calling is debugger. So how you do that? So basically you need to set up breakpoint, run the binary or the program that you want. Once the breakpoint has been triggered, then you need to go into modules. From the modules list, select kernel 32 in this case, and then from here you will see all the functions that you can list from kernel 32, and then press Ctrl F to search, and then we're gonna look for is debugger present. If we will find only one, double click on it, and it will take us to the champ of directly from kernel32.dll, as you can see here. So what we can do here is to press F2 to set up a breakpoint. So now every time a process reaches this is debugger present function from kernel32, doesn't matter what, if this binary, not any binary, is this binary, if it try to reach this function, then it will stop the execution on our breakpoint. So now if we list our breakpoints, we will see that we have this one on the start, and then a new one on isDebugger present function on kernel 32, right? So if we run it, we will see that now we choose hit that breakpoint. See? So now the question that you might have is, how can we know if it is using isDebugger present or not? Well, if you start debugging the binary itself, and if you follow the flow of the binary, you will end up knowing exactly which functions are being called. But that will take some time, of course. A clever trick will be to set up breakpoints on all the functions, on all the API functions that you can get not only from kernel 32, but also from NTDLL. Here, and then set up the breakpoints on all the functions that could be used as anti-debugging techniques. How can you know of those functions? Well, this reference, the ultimate anti-debugging reference that I think I already spoke about this on on some other videos. It's like the Bible of the anti-debugging techniques. You will see that if you, well, it's gonna list a lot of them, almost all of them actually. And if you go into the APIs on the section 7, you will see that we have all of them. Yeah, almost all of them, sorry. But here's one, is debugger present. This is the one that we are triggering. The kernel is 32, is debugger present, functions has been introduced in window not defined. So basically it returns as a non-zero value if a debugger is present. So basically will give you one or if the debugger is present. And of course there are others. That's just one, right? So there are other functions that can be used, and not that particular one is a Windows function to know without enough if there is a debugger present. But there are other functions that can be used and not and they are not the main objective of those functions are not specifically tell you if there is a debugger present or not, but it can be used for that as well. And there are also a lot of undocumented functions that can be used to check if a debugger is running or not. Yeah, if you want to go deeper into those and know more, you can choose come to this yeah, you can choose get this PDF and then choose read about those. This is quite well explained. But in order to make your life easier, what I just made is this script. So I'm gonna show you how it works. So going back into this binary, this binary only have one anti-debugging technique, but I think it will do just fine to show you to use it as an example to show you the script itself. So basically, how do you do it? Well, let's start from the beginning. Stop, remove all the breakpoints. So now if I list my breakpoints, I have nothing, and I'm on the binary. Yeah, exports, nothing. So Shift F2, and then from here, well, I can import it, then say anti-reversing, or you can run it from file, script file, or you can choose put it here and then run it from here. So I think I put two. Let me. There you go. Yes. So what it does, so basically this script is gonna set a breakpoint on all the kernel 32 uh, offset on all the APIs. So if any of these are a hit, then you will know. it's gonna do the same for NTADLL and also for user 32. But in order to not make it that intrusive, so it will the type of breakpoint that are set, the breakpoint itself, they are just gonna trace it. They are not the breakpoint are not gonna break. So it's gonna continue execution. It's gonna trace it and it's gonna log it on the output. So you will see when a breakpoint is triggered. And if you want to actually set the breakpoint without this and change the status to break instead of non-break, and only trace, you can do it as well. And by default, it comes with only kernel 32 enable. But if you want to enable the breakpoints for NTDLL and user 32, you can choose do this, right? But remember, as I mentioned before, that a lot of anti-debugging techniques use functions that are not meant to be used as an anti-debugging technique. Yeah, and also undocumented functions. So uh, enabling everything is not recommended. You should go little by little. But with but like this is way faster than doing it manually, of course. So if we want to run it, it will tell us that, oops, it cannot be run because there is no process currently being debugged. So what we need to do is to also, if we try to run it and the process is just running inside the debugger, it cannot set a breakpoint because the process needs to be suspended. So if you want this script to do it automatically for you, you can uncomment this, run to and get the debugger event, and it will choose begin the execution and stop it and suspend it for you and set the breakpoints. That's also not recommended. What I would recommend is that if you are let's say I close this, and let's say you are trying to solve this binary. Let's dig into the uncompressed one, so it will be easier to understand. So we put it here, and this is how it should be the normal execution of it, the normal flow, I meant. So basically we dump the strings. This is typically how you solve this. So you found that congratulations message, you go cross the references, and then you found, oh yeah, I want to go here, you set it, and then you start reversing it, and then maybe drop a breakpoint on the beginning. And then if we run it, you will see that is just closing, right? So we say, oh, well, must be an anti-debugging technique. So we can go into the start function, put a breakpoint there, because it's not actually stopping into the breakpoint that you wanted. If you set up these two breakpoints, you will see this is a start and this is a breakpoint on the function that you wanted to stop on this sub. All right, so now let's use the script. F2. Now we say stop on the start. We say file, script command. We grab this. And then what's going to happen now is that it's going to set for kernel 32 all these breakpoints. We press run, and then we can see that here we have it. Yeah, it says API anti-debugging breakpoints for IDA Pro by Sako, and it is actually based on the Ultimate Anti-Debugging Reference by Peter Ferry. That's the PDF that I show you. And the breakpoint properties are traced on, the breakpoints are enabled, but they are set for no break. If you set the config of if you set the config to anti-DLL and we enable it, then besides the kernel 32 breakpoints, you will also get the one for NTDL and same for user 32. Well, you can see that it found those addresses, and then it set the breakpoint for it. And actually, now if we go into the breakpoint list, let's put it here. You will see that we have all these breakpoints. Let's choose open one. Let's open the one for EasyBugger present, just to show you the, the type of. If we click edit, we will see that it is enabled. It is tracing. Then tracing it is enabled, but it is not breaking. If we want to break the execution, we can enable it. We can change it there, or we can also change for all of them on the script itself. But now, if we run, what it should happen is it should detect that. It should detect from the list of breakpoints the type of anti-debugging technique that is being used by this binary, and uh, tell us about that on the message log. And as you can see here, it says anti-debug triggered. It detected that the script detected that it was a kernel 32 is debugger present, and also gives you a little bit of information regarding that particular anti-debugging technique. So now what you should do if you want to follow along and bypass this anti-debugging technique, in this particular case, it's quite simple because it's debugger present, and you know what you need to do. You need to set a choose a, yeah, set a value. So what you can do if you want to break into that, you can choose is debugger present, because now you know it is debugger present without questions, and you can go into that. It matches is debugger present, and then we can edit and say yes, break on that one because it is actually using it. So now if we continue the execution, we can see that we are into is debugger present, and then from there you can start solving the crack me. And of course, if there are any other anti-debugging techniques triggered during runtime, and is using NTDLL or kernel 32 or user 32 as described on the PDF and on the script, it should the script should detect it, and you should trigger a log and let you know that those are the anti-debugging techniques used. Okay, guys, uh, I hope you like it. I hope you enjoyed the video. I'm gonna link on the description of this video the scripts that we were using, and also maybe the links for UPX, P-tools, P3 tools from BlackBerry. Yeah, and if there's something else, I will check it up, whatever we use on this video, so you will have it on the description, so you can actually redo at your own pace what we just have done here. Okay, guys. If you like the channel, please subscribe. If you like Exploit Pack and you want to learn more, go to exploitpack.com, and then you can try the software. And there are some new updates coming for Exploit Pack in the following weeks, actually. Yeah, and if you want to get involved into the project, or you want to chat with the community, join us on the Discord channel. So, thanks guys. I'm gonna stop the video and see you in the next one. Bye.